let me start with this question number 2. I'll do the modeling part. Once you do the modeling, the Nash becomes not that interesting. Okay, actually, in both questions, the modeling might be a bit more interesting. So, a firm and the workers' union has to decide on the wage rate. They go to an arbitrator. So the method that the arbitrator uses is each one in a seal bid writes a number. The firm writes down how much it would like to pay. The workers' union writes down how much they would like to pay. And then the arbitrator has an ideal amount, which is unknown to both agents, unknown to everybody except the arbitrator. Okay? So the arbitrator chooses the number which is closest to his ideal amount. If they are of the equal distance from the ideal amount, then the arbitrator chooses one of them at random. Flips a coin. If it heads, chooses the number, quantity, the rate announced by the firm. If it's tail, chooses the rate announced by the workers' union. Okay? So, and then we said, even though the ideal amount, the ideal wage rate that is in the mind of the arbitrator is unknown by both the firm and the workers' union, they believe that it's uniformly distributed in some interval, 0, alpha. Okay? So, the first thing is we have to model the situation. So what is the set of players? Firm and workers. Arbitrator is not a player here because he doesn't freely choose an action. His action is already dictated, okay, in the story. He doesn't freely choose an action. His action is already dictated in the story. So the arbitrator is not a player. So we have two players. We could say player 1 or player 2, or keep it simple, firm, F for firm, W for worker. So what is the strategy set for the firm? Any number between 0 and alpha. And that's the same for the workers' union. Again, you should explain what a strategy means, so I'm not going to write that. So a number, SI in the interval, SI in F of S, denotes the wage rate that the firm proposes. SW in capital SW denotes the wage rate that the workers' union proposes. You should write these down, okay? So now the interesting part. So firm announces SF, workers' union announces SW, okay? What is the numeric representation of the preferences of the firm? Well, we're given in the story that the firm prefers a lower expected wage rate to a higher.
Alpha minus wage star, which is the wage determined.
Sorry,
Alpha minus the wage star.
Alpha minus S star. Okay.
S star is the wage that the arbitrator chooses.
Okay, so what is that?
It's determined by the absolute difference between both of them. For example, let's set the ideal wage to be beta.
Mm-hmm.
SF minus beta, the absolute difference between
We look at SF minus beta and?
is greater than the absolute difference between SW and beta.
Okay.
Then SW wins, so S star is SW.
So if this is the case, then we have alpha minus
Alpha minus SW.
SW, if this is the case. So far, so good?
Why do we have alpha?
Why do we have alpha?
You don't need alpha.
We don't need alpha, just minus SW, right? Because he prefers paying less to paying more. So far, so good? And then there is this if part. So far, so good? So far, so good? By the way, did everybody submit their homework? I will not accept any homeworks after this point. Okay. So far, so good? Well, let's check. As I always say, first, when you're writing things, write properly. So sometimes we economists have this habit. We just say UF equals to this. Well, UF is a function, so it has an argument. We usually say, well, that's in our mind. That's why we didn't write it. We're saving ink. That's a bad habit, okay? If it's a function, it has an argument. Write down the arguments, okay? So UF evaluated at SFFW is equal to this animal, and then there's more. Always do your check. Once you're done, put the marker down, scratch your head, ask yourself, does it make sense? Well, one easy way to check is accounting. Is everything on the right-hand side accounted for? So there is SW. Where does it come from? It came from here. No problem. So if there was this alpha here, we could have put alpha there. I would ask, there's an alpha. Where did it come from? It didn't come from the left-hand side. But it's a parameter. It's a given fixed quantity in the story. So it comes from the story. It's a parameter of the problem. Okay? Good. SF, where did it come from? Came from the left-hand side. It's not a parameter. It's a variable. So that's also counted. And then I see a beta.
Beta is exogenously given as well.
So what is it? Where is it given in the story?
It's the ideal wage that the,
And what is that?
it's a number between 0 and alpha.
But which number? If I'm going to evaluate it, I need to know that number.
We know the expected beta. So expected beta is alpha over 2.
So do you mean that it's the expected value of the beta, or?
No, we don't know.
So it's not beta. But if you don't know, how are you going to evaluate this function? If you don't know it, how are you going to find best responses? If you're the firm, if you don't know what beta is, how are you going to evaluate that? Yep.
So actually, in the question we have lower expected wage, but we are writing their absolute wages.
Okay. So it's the absolute wage if we had known the ideal point of the arbitrator. So that's what we have to do. You see, let me draw you a picture. So that's 0, that's alpha. Let's say that the firm chose SF, the worker chose SW, okay? We could have been the other way around too. So if the ideal amount of the firm, of the arbitrator is here, what is the wage they selected? SF. It's here? SF. It's SW, 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 right? So if the ideal amount is in this range, the arbitrator will choose SF. If the ideal amount of the arbitrator is in this range, the arbitrator will choose SW. So I'm the firm, okay? I don't know what the ideal amount of the arbitrator is, but I know that I have a belief that anything in this region is likely, and actually, the ideal amount for me is a random variable, which is uniformly distributed over the interval 0, alpha. Okay, so my loss would be minus Fs with what probability?
The ideal rate is less than SF plus SW.
Okay, if the ideal quantity of the arbitrator is in this region, which is, so if it's uniformly distributed, what will the probability be? with what probability will the arbitrator, with what probability, I should get it. With what probability would the ideal amount of the arbitrator be in this region? Sorry, SF? So it's going to be this length divided by this length, which is what your friend said. 1. But the arbitrator's ideal amount could be in this region. Okay? If it's in that region, the arbitrator will select SW as the wage rate. So the firm's loss, in a way, would be minus SW. And with what probability will it be this? With 1 minus I'll put, well, with this probability. And then, well, if the arbitrator's ideal amount is at the center, then he's going to flip a coin. With 1/2 probability is going to be here, with 1/2 probability is going to be here. But with what probability will be the arbitrator's ideal amount just exactly in between the two quantities? With 0 probability. So I really don't have to write that part. I really don't have to worry about that part. Okay? So this is actually equal to US of SFSW. That's it. This is the expected wage rate. Well, the negative of the expected wage rate for the firm. First you.
How did we get to the ideal wage rate with which the arbitrator chooses is SF plus SW?
No, it's not the, so you see, if the arbitrator's ideal point is in this region, he will choose SW. Okay? So with what probability will his ideal amount be in this region? Well, it's going to be 1/, so this length divided by this length. Okay, oops, I'm sorry, I had the, so I said this length, okay, alpha, divided by this length. So I should have said, so what is that length? Well, this length is 1 minus SF plus SW over 2. Okay, so divided by alpha. I should have written it here. Sorry about that.
It is alpha minus
Oh, so put, yeah. This is a better way of writing it, which is the same as saying 1 minus alpha. Okay, but let me write it this way. This is better. Okay? So far, so good? Of course, this is when SF is less than or equal to SW. Then I have to write the same thing, do the same exercise when SF is bigger than SW. Okay? That's it. Any questions? Yes, sir. Okay, let me. So, assume that we such that SF is less than SW. Okay? So, here we have SF. Here we have SW. Here we have SF plus SW over 2. Okay? So, if the arbitrator's ideal rate is less than SF plus SW over 2, then the arbitrator will choose SF, because SF is less than SW. Okay? So if the ideal amount of the arbitrator, ideal rate of the arbitrator falls into this region, then the arbitrator will choose the wage rate SF. Okay? So if the wage rate SF is chosen, that's how much the firm will have to pay. That's the rate at which he will have to pay, which is bad news for him. So it's like losing this much money. But with what probability will he lose this money? Will he be giving out this money? Okay. So he will be giving out this money with the probability that this amount will be selected. With what probability will this amount be selected? Well, that's the probability which the ideal amount, so that's 0, that's alpha, that's the probability that the ideal amount of the arbitrator falls into this region. Okay? Okay, so far so good? So we said it's the ideal rate of the arbitrator is uniformly distributed over the interval 0 alpha, which essentially means the probability that the ideal amount of the arbitrator is in any interval is proportional with the length of the interval and is independent of the location of the interval. Okay? So if you take this length, the probability that the arbitrator's ideal amount is in this interval is the same as it is in this interval, the same as it is in this interval, the same as it is in this interval, and it's directly proportional with the length of the interval. The larger, the higher the probability. The smaller the interval length, the smaller the probability. Okay? So that's the uniform distribution that we know from probability theory. So the probability that the arbitrator's ideal amount is in this interval is the length of this interval, which is SF plus SW over 2 minus 0, that length, divided by the length of the whole interval, which is alpha minus 0. Okay? So with this probability, the arbitrator's ideal amount will be in this. The arbitrator's ideal rate will be in this interval. Hence, with this probability, the wage rate will be SF. But the arbitrator's ideal wage rate could be also in this interval. If it is in that interval, then the wage rate will be SW. With what probability will it be in this interval? Again, because of uniform distribution, it's going to be the length of this interval divided by the length of the whole thing. So that's alpha minus SF plus SW over 2, that's this length, divided by alpha, that's the whole length. Okay? So what do? We add them up. This is the expected wage rate given the firm's belief about the ideal wage rate of the arbitrator. This is his expected wage rate. Okay? So far, so good? Of course, and then we do the same exercise with SF bigger than SW. Okay? Do you want me to write that too, or you get the idea, I hope. Okay? The coin flip part is not important because that's, with what probability will the ideal amount of the firm be just at this? Well, actually, there's one exception. There's one exception, okay, to what in this case, what is the probability that the ideal rate of the arbitrator is of equal distance between those 2 points? That is equal to SF plus SW over 2. It's 0. It's the length of this interval, which is 0, divided by alpha. But there's an exception to this. Okay? If SF is equal to SW, with what probability will the arbitrator be of equal distance from both declarations? With probability 1. Okay? So maybe you should look at this case separately. But if they both announce the same amount, the arbitrator will choose the same thing. Okay? Any questions? So once you have that, that's a simple function in SFSW. Write them, draw the graph. Well, actually, the first thing I would do is simplify things. And when you simplify things, you'll see that a lot of things cancel out. And suddenly the problem becomes very trivial. Okay? So I'll leave that here. Go to problem 1. You had a question about?
No, so it turns out to be the nice solution. SF equals 0 and SW equals alpha, right?
Exactly, yes. So when you solve this, you see that the Nash solution is going to be where the firm declares, I don't want to pay anything. The workers' union declares, we want everything. Okay? Any questions? If we have time, we can come back to it. But let's go to question number 1 so that we'll satisfy both sides. So the interesting part of this was the modeling part. I wanted you to get some practice using a little probability theory. So here, in this problem, there are n locations where two competing firms will open stores. Okay? At each location, a company, a firm, can open at most one store. Okay? So we have k locations. Location 1. Location 2, location 3, k minus 1, k. And as the index increases, so the value of location 1 to both firms is V1. The value of location 2 is V2, and V2 is bigger than V1, and we keep going on like that. Okay. Firm 1 is going to open N1 stores. Firm 2 is going to open N2 stores, where both of them is less than, did I put equality? Yeah, less than k. Otherwise, if N1 was bigger than k, the condition that, well, they might just say that we're not opening some of the stores, but okay. So these are the number of stores that they must open. They're going to open it, okay? So the first question part is, okay, model the situation as a strategic form game. So again, the easy part, who's involved? There's only 2 players, firm 1 and firm 2. Now the interesting part, what is the strategy set of firm 1? Yep.
I said that it's a vector, so we're going to write a vector.
Okay.
1 times k.
Wait a minute, let me go step by step. So let's concentrate on firm 1. So S1 is the vector, is a list.
And let's call that vector
So the elements of it, ML, or so how many components does this vector have? K. So that's an element of something to the power k. What to the power k? So what is the first number?
It's either minus 1 or 1.
Minus 1 or 1. So we can say that it's minus 1 to the power k, the Cartesian product of this set with itself, k times. Okay, so maybe we can say this S11, S12, S13, S1, k. Well, actually, that finishes it, right? Do you have any other condition? You don't have any other condition?
If we choose minus 1, then
Okay. So then your friend has to give explanations. Yep.
we have to set also another conditions because we are only opening N1 stores.
Exactly. So maybe we should have more conditions. Which are?
If we switch from 0 to 1, not minus 1,
Okay.
then we can do the summation of S1i equals
Such that summation L from 1 to k S1L is equal to N1. So again, you will need explanation where
Where S1 and L
S1 equal to, well, I will not write it here. S1 denotes the action of firm 1 opening a store at location L if and only if SIL is equal to 1. Okay? So that's a possible strategy set for player 1. Okay? So that's one way to do it. You can do it with the -1, but then this is easier to handle. In that case, you should only add up, assuming that 1 means opening a store, -1 means not opening. Then you sum up only positive terms. Yes, sir?
Can we say just S1 includes all subset of the set 1?
Right. So your friend's suggestion is? Your friend's suggestion is? So small s1 is a subset of locations such that, right, the cardinality of S1 is equal to N1. Is that what you had in mind? Okay. So where S1 in capital S1 is the list of locations at which firm 1 will open a store. So, yes, both of them would work.
But we should differ the set of itself. Because we cannot open K.
We cannot open, what do you mean? We cannot open K stores?
Yes, we cannot open.
But that's takes care of it, right? We exactly open N1 stores. Not more, not less. Exactly open N1 stores. Yes, sir. What if agent? Can you? I can't hear very well. I have a ringing in my ear.
Another possibility is that agent decide not to open a store.
Not to open. Okay. Okay. So if K is equal to 5 and 1 is equal to 3, if firm 1 says, I choose this strategy, this time remember S1 is a set. If he says, I choose this strategy, it means that he's opening a store at location 1, location 3, and location 4, which means that he's not opening a store at location 2 and location 5. Okay, so that information is also in here. You can use either one.
In this case, how can we show the preferences?
Well, that's the next step. Okay, so, but this and this so far works. So the next step is in the modeling, the preferences or a numerical representation of the preferences. Let's start with this. If this is what you choose, what would you have as a numeric representation of the preferences? So if this is what we choose, yep. So again, let's write it for player 1. BL or simply, okay. So if S1L is 1 and S2L is 1, it means that they both opened a store there, and in which case we said the gain, the local gain of firm 1 from location L is 0. Well, BL times 1 minus 1 is 0. If firm 1 opened a store and firm 2 didn't, then the local gain of firm 1 from that location is BL times 1, which is exactly what we want. If firm 1 didn't open a store at location L, but firm 2 did, then the local gain of firm 1 from location L is minus BL. So that seems to be covering the case. That's it. Okay? So far, so good? Yep. This is if we take the strategies like this. Like this one. So what if we took the strategy sets like this? In that case, what will we have? Actually, initially, your friend wanted to write it like this. So that will give you a clue. Yep.
We can say that the equals the summation of VL, or L is a number in S1 minus the summation of VL. So L is a number on S1.
Exactly. That's it. That's the extension to this. So both of them works. Okay? So far, so good? Yes, ma'am.
How do you find the best utility function?
How do you find the best responses? By the way, what was the question? The question was, find the set of dominant strategies of each player. So one thing, actually, that's something that I later on, I was, so when we're talking about, dominant strategies, strictly dominant strategies, nice solutions, I realized that I kept using best responses because they're powerful tools. But you don't always have to do that, okay? Actually, I was planning to do an example where you don't use best responses, use directly the definition of it, okay? Direct definition of dominant strategies or direct the definition of Nash solutions. So to find here, we said find the set of dominant strategies. You don't really have to find best responses. We can, and we'll do it in a minute, but you don't have to. But if you can use the definition of dominant strategies directly, but to use that, most of the time, how that works is you make a guess, okay? You say, well, this game doesn't have any dominant strategies, and then you try to prove it using the definition, or you say that, well, this strategy is a dominant strategy for player 1, and then try to show that, okay? So if you were to guess for a dominant strategy for player 1, do you think player 1 has a dominant strategy? And if so, what do you think it is?
And one stores with the highest indices.
Choose the N1 stores with the highest value. So open your stores at the most valued N1 stores. That's the. So what you can do is directly show that that strategy dominates every other strategy of player 1. That's one thing. But if you want to use the best response, which utility representation do you prefer, this one or this one? The first one, okay? So what do? We're trying to maximize U1 given S2. Well, if S2 is fixed, it means that this term is fixed. So how do you maximize this function? Okay, so these are going to be zeros or ones, and you have only N1 of them by putting all of them at the most valued function. So actually the utility function is a very simple function. So I would say B1 of S2, irrespective of what S2 is, okay? No matter what S2 is, that's a constant here. And it doesn't change the maximizer. B1 of S2. If we use this notation, it's going to be 0, 0, 0, 1, 1, 1, 1. And how many these? Well, I'll write it in a more compact way. It's S1 where for any L from K minus, so let me, N1 plus 1, so we have N1, K minus N1 plus 2, well, N1, SIL is equal to 1, and for any L from 1 to K minus N1, SIL is equal to 0. Okay? Or if we use this notation, it would be easier. Just the elements from K minus N1 plus 1 to N. Okay? Sorry?
N1 should be K.
Oh, yes. Well, wait a minute.
Yeah, the last one is K.
Oh, yeah, that's the Kate agent. That's the Kate location. Getting tired. Yeah. Okay? So that's the best response. Well, there's a single best response, which means that actually firm 1 has a strictly dominant strategy, which means that this game has a strict dominant strategy solution. Both firms opens their stores at the most valued NI locations. Okay? Any questions? Any questions? Yes, sir. No, there wasn't. Oh, if there wasn't. That's the question. So, but in the story there was. So, sure. Then you have to write the. This part doesn't change, but this part will change. So, what was your question? So, if at location L, I open a store.
I didn't open a store, and the other firms opens.
Doesn't give a negative outcome. So in that case, what would be your friend's suggestion is, let's change the model. Maybe, which one is more realistic, I don't know, we'll try. So if firm 1 doesn't open a store at location L, but firm 2 does, in our case, firm 1 has a local loss of minus VL. Your friend says that, well, if he doesn't open a store there, he shouldn't have any gain, he shouldn't have any loss. In that case, what would be the numeric representation? Yep.
Let's say that as the first part as it was VL times S1L.
VL times S1L.
Minus summation of VL for L. The part where
Sorry?
S1L and S2L, they are both 1.
Where? They're both?
Where S1L and
S2L are 1. So how would you write that? By the way, we still have, if we both open a store at the same location, my gain is 0, right? Okay. So we should, if I open a store and you open a store, we should subtract it. But if I didn't, we should not subtract it, which is what your friend said. If both S1L and S2L is equal to 1, we should subtract. Otherwise, we shouldn't. What is the simple mathematical way of writing this? Well, you cannot intersect. These are numbers. Right? If one of them is 0, it means that if this is 0, it means that firm 1 did not open a store. We don't subtract. If this is 1 but this is 0, it means that firm 2 didn't open a store, so we don't subtract. Okay? So that would be the case, but then, we have to so does the best response change in this case? Yeah, because this time we have S2 held. So unlike the previous case, when this is fixed, it depends on this. So what would be the best responses? That I could leave as an exercise to you, or yeah.
For example, if he opens in several locations, I will open into the highest empty locations, or during where he hasn't opened.
So if, for example, he has but then we have to prove that. So we have 1, 2, 3, k minus 1, k minus k locations. So if firm 2 occupied this location and this location and this location, what your friend suggests is that the best response of player 1 is to allocate here, and then maybe here, and then here, and then here. So far, so good. But then there are things that we have to be careful about. You see, he has to open N1 stores.
If there are not N1 free locations,
Uh-huh.
he will occupy as many as locations there are empty, all of them,
Uh-huh.
and then he will choose right.
And then the rest will not matter. Okay? But you see, your friend is making a guess. So the next step is to prove it. Okay? So, but if his guess is correct, what can you say about the dominant strategies? It would be empty because there's no single best response. But then the next thing you would look at too would be Nash solutions of the game. Okay? Sure. Which one? The modified version or the? Okay.
You said that in the modified version, when first player does not open a store but the other one opens, we're not penalizing, so it's 0. Yes,
Yeah.
So I'm not clear why in the second summation, why do we have S1?
Here?
Shouldn't it be 1 minus S? Because for the case when S1 is
You see, the reason why we have it here is, the thing is, we've added a lot of values. So if I open a store at location, say 1, then V1 is added here. Okay, so V1 comes here. But also, if you open a store at location 1, I shouldn't have V1, I should have 0. So if we both open a store at the same location, my local gain from location L is 0. Okay, so that's why we have it. So I want to subtract what I had added. I want to subtract it back if I have opened a store at location 1, and also if you have opened a store at location 1. Okay, that's why. So your idea was having it like this.
I thought that we were doing it like whenever, for the indexes that we open a store, we add VL for those indexes, and then I thought that we were, but I understood my mistake.
Okay, so yes, sir.
If we have in the modified version, if we have N1 and N2 greater than K over 2, wouldn't it be any strategy?
You had N1 plus N2.
N1 greater than K over 2 and N2 greater than K over 2. Wouldn't we have any strategy would be a Nash solution? Like any strategy profile.
will any strategy profile be a Nash solution? What do you think about that? So
In the modified version.
in the modified version. So here, N1 plus N2 is bigger than K. So the total number of locations needed is more than what is available if everybody is to open a store at a single location. You change your mind? Why? But you see, I think that's also an interesting question. And you should keep asking questions like that to yourself. So you should not restrict yourself with the questions that we ask you. Okay? So I think your friend's starting point was interesting. What happens if we modify this game? Okay? I think we get another interesting game. Okay? And then we started making some guesses. And our final guess is, well, guesses about the parameters. So if the parameters are such that your friend initially was saying that anything is a Nash solution, did you change your mind?
If we stick to the best response answer I gave, then they are.
Okay, so then you have to show that. Unfortunately, our time is up, but those are good exercises to think about. And then you can do the same thing with other problems. For example, in one of the homeworks, I gave you a problem where the two goods were complements. When the price of good 2 increased, the demand for good 1 decreased. I think this was homework number 4. Okay? So what would happen if they were not complements? Okay? What if they were substitutes? Okay? When the price of good 2 increases, the demand for good 1 increases. How would that change the best responses? How would that change the Nash solution? How would that affect Pareto efficiency? And many, many more questions. So with each question that actually, almost all homework questions that we asked you, you can generate a whole bunch of new, interesting questions. Okay? That's it. Have fun.